Hi students, good morning. Pushti sir again. I'll be discussing some important points in mechanics, especially some question based on constraint. Okay, just I am giving a simple question here. You see a string, a massless, inextensible string passing over a frictionless small pulley attached to the roof. One end of the string, a block of mass m is hanging at the end B of the string. Other end of the string is pulled horizontally with a constant velocity. This constant velocity to the right by a person. So one part of the string is vertical, that is OB, and the other part of the string is slant, that is length is L. L is variable, of course, as the man moves, L will change in value. And the angle between this OB and OA, that is theta. And that point A is at a distance h from the height of the pulley. Pulley is given as O, symbol O. Pulley is massless, pulley is frictionless, string is massless and inextensible. That is string. Okay. So if the end A is being pulled with a constant velocity to the right in a horizontal direction, then find out when the angle theta is 60 degree, find out the velocity of block, its acceleration of the block. I have given a series of questions. Determine the velocity and acceleration of the block when the theta is 60 degree. Find the tension in the string at that instant. Find the force applied by the person at the end A. Find the angular acceleration of the part of the string OA. OA part of the string, this OA part. What is the angular acceleration of this? Find the power developed by the person pulling the string. What is the work done per second by the person in pulling the string in horizontal direction? These a few questions I have asked you, 5 questions. Okay, let us answer the questions. First point is how to find the velocity and acceleration of the block. Very nice. It is an inextensible string, as you know. If an inextensible string passes over the fixed surface, over fixed surfaces, all the surfaces on which it's passing should be fixed with the reference frame. Means with respect to ground, they should be fixed. It is passing over a pulley which is fixed with respect to ground. Then the component of the velocity along the length of the string for each point of the string, the velocity component along the length. This point velocity to the right is a component along the length is this one, this VAR. So similarly, other points, they may have velocity some other direction, but the component will be along OA will be some value. So the component of the velocity along the length of the string for each point is same. Length of the string is same in magnitude for each point of the string. Along the length component, the velocity component along the length of the string for each point is the same in magnitude. So that way, if I say this BOA is the string, every point of the BOA string, we have velocity component along the length of this string should be same in magnitude. For example, point number B, the velocity is VV as I shown you upward direction. but that is fully along the length. But here A, the velocity is to the right. So along the length it will be the sine component of this V naught sine theta. So that way the V naught sine theta, that is VA along the length, VA component along the length should be equal to VB, which is completely along the length. So I wrote straight away this VB is equal to V naught sine theta. Equation 1. Okay, that you must be knowing. Very simple concept. Otherwise, you could have done this work done by the tension force is 0. So T dot V naught plus T dot VB, you can add to 0, you will get the same answer. Okay, that is simple question. Then angular velocity of OA, how much? What is the angular velocity? Let's find out. This OA is what? Omega. That is nothing but d theta by dt. Yes or no? Okay. So d theta by dt, how much? Tell me. Angular velocity d theta by dt, how much? This is the string OA. The A is having a component along the length at V naught sine theta, and another component, velocity component, perpendicular to the length of the string, that is VA tau, V naught cos theta. Omega into this L must be VA tau. You must be knowing this. Yes, omega into L, omega cross L bar should be VA tau bar. If I use this, I can use. So that gives me omega L V naught cos theta. So that way I'll write omega of that OA length is V naught cos theta, V naught cos theta by L. Just see from here, V naught cos theta by L. And L is h by cos theta. Yes or no? You see the diagram. This is L, this is h, this is theta. So L is h by cos theta. This I have rewritten here. V naught cos theta by h by cos theta. So this is your omega is V naught by h cos square theta. Okay. This is omega. Then the question was asked, find the angular acceleration of OA. We'll see that a bit late. But what is the acceleration of the block? That is also a question. If I know the velocity of the block B, then I can take the derivative, time derivative of equation 1. I'll get the acceleration of AB. So I get V naught cos theta. Just see take the derivative of equation 1, dVB by dt, that is AB, that is V naught d theta d by dt of sine theta. That gives us V naught cos theta d theta by dt. But d theta by dt already I have found from this equation 2, that is V naught by h cos square theta. That's what I wrote. V naught by h cos square theta d theta by dt, V naught cos theta, V naught square by h cos cube theta. Okay, since AB is positive, we'll find this positive only. Let's see this. So the theta is less than 90 degrees, so cos cube theta is positive. So we'll have AB positive means whatever arrow mark I have given, upward acceleration arrow mark, that's correct. So it is having an upward acceleration of how much? We are having upward acceleration of this V naught cos theta d theta by dt, V naught square by h cos cube theta. So this way got. Okay. That is acceleration of B. Since AB is positive, it is obviously as per the arrow mark direction, that is upward direction. Now find tension. He is asking, find tension in this string. Find the tension in string. Question number 2. Let's find out Newton's law. Apply Newton's law to the block hanging. How much it will be? T minus mg is upward direction net force is equal to mass into upward acceleration. So T is equal to this. Okay. This is the free body diagram of block hanging, and this is the Newton's law for that. So I got the tension is m into g plus v naught square by h cos q theta. We'll later put the numerical values. Then this is tension, means tension throughout this massless inextensible string should be same. So here tension will be along this. So T. So here I draw that point A. This is T. This must be F. You may say, why F is not in this direction? That's the question in your mind. You see, A is a massless point. Net force has to be 0. T is along the length of the string. So F must be opposite to that direction. That is along the length of the string, opposite to T direction. Otherwise, we will have a net force on a massless body, which is not acceptable. Okay, net force on a massless body must be 0. So force by the person at the end must balance T, as net force on a point A, which is massless, must be 0. Force at point A is F. This is by the person who is pulling. He is pulling in horizontal direction, but exerting a force opposite to the string length at A. So force at point A is equal to same F, that is equal to magnitude of tension, that is m into g. This F 5. This is question number 5. F is same as T in magnitude. Then what is the power developed by the person? What is the power developed? Let us see what is the power developed then. F is along the length, whereas F is along the length, whereas velocity is to the right. Angle between them 90 minus theta. See this main diagram. If this is theta, this is 90 minus theta. Yes or no? So that is F in this direction, V in this direction. So F V naught cos 90 minus theta should be the work done per second. Am I clear? So power developed by the person pulling the string at A is equal to F dot VA, F V naught cos 90 minus theta, F V naught sin theta. And F already I know, this value is F. I substitute that, and V naught sin theta. Okay. Now let us substitute the numerical value. Till now I have not calculated the angular acceleration. Okay, let us calculate the numerical, put the numerical values and find the numerical value of our the answers, all the parameters. VB, V naught sin theta from equation 1, how much it is? 2 root 3 meter per second. AB, V naught square by H cos q theta from equation 3, that is 4 square by 2, 1 by 2 to the power 3, because this cos q theta cos 60 is 1 by 2. So this becomes how much? 8 to 2. So 1 meter per second square is the acceleration of the B. Remember this. And acceleration of A, how much? Let me ask you this simple question. I'm pulling it with horizontal constant velocity. There is no vertical velocity and no vertical acceleration either, because continuously vertical velocity 0 means there is no vertical acceleration, and horizontal acceleration 0 because V naught is constant. So A is having 0 acceleration, whereas B is having acceleration 1 meter per second square. Understood this? So this is a crucial point to see, that AB and AA need not be same, because there is a angular motion is involved here. Am I clear? So AB is, we found out T is equal to, as you know from equation 4, already I have given this, all these equations. So you can see this equation 4, this is the T. Just substitute the values. V naught is 4 meter per second, h is 2 meters. So this 10 plus this is 1, this is 10. So 11 Newton is the tension. Force at end A, same as I told you again. So in the diagram, force at end A is same as T, that is also 11 Newton. Power developed person, power equation I got from equation 6. Let me write this from equation 6. Okay. You substitute the values. This is 11. This is V naught is 4. Sin theta is root 3 by 2. So it becomes 22 into root 3 watt. Now find the acceleration of the OA. I'll take the accelerated time derivative of omega. Omega already found out. V naught by h cos square theta. Just take the accelerated, take the time derivative. So time derivative will be, if this is the omega, then this must be the acceleration. I put, if acceleration negative, then it's opposite to omega, but I put its omega direction here. Let us see what is acceleration we are getting. D omega by dt, omega value is how much? Take v naught by h cos square theta, take a time derivative. So if I take time derivative, just 1 second. So time derivative will be okay. There is some disturbance. Okay, time derivative omega in equation d omega by dt. So that is because v naught square v naught. Let me see what was omega. V naught by h cos square theta. Take time derivative. V naught by h you take outside. Cos square theta derivative will be minus 2 cos theta sin theta into d theta by dt. So it is minus 2 v naught by h cos theta sin theta, and d theta by dt is the omega. Omega again v naught by h cos square theta. Already omega you know. Because let me write from equation 2, omega we wrote as v naught by h cos square theta. Time derivative of this. Okay. So that gives us minus 2 v naught square by h square cos q theta sin theta. So substitute the value is minus root 3 by 2 radian per second square. Minus means what? If this is omega, then this is alpha. That's what I have written in the note. This is note second point. Negative sign of alpha implies that alpha is opposite to omega. It is angular deceleration effectively. So note 1 is power developed by the person is also equal to rate of gain of total mechanical energy per second by the hanging block, because there is no other component which is gaining energy. So you can check it also that way. So P is equal to d by dt of TME of the block, that is mgv, plus d by dt of half mb square, that is mvb ab. You get this also. That just check it. Just one point to this just one point for your checking purpose. Am I clear? So this is, I hope this must have clarified many points which you might have faced in your studies, but I think many things have been clear in this question. So similarly, I'll give you some more questions on this type of angular kinematics as the day progress. So this is my credential. All of you know me by now. So we'll soon give the next question for you, very soon. So have a nice day. If you have not understood this, go through this video again and again till the idea settle in your mind. In case of difficulty, you can contact me also. I've given every number, my number also. Thank you all. Have a nice day.